I'm Antonis Parasiris, your presenter for ship routing and harbor safety pilot in Heraklion Port, where we're developing a digital twin of the ocean to address challenges encountered by the shipping industry and the Port Authority of Heraklion Port. Here you see the Port of Heraklion, where it suffered extreme events regarding wind, waves, and sea level. To support day-to-day operation, access to very high-resolution forecasting models and in situ sensors, as well as custom warnings and alerts, is a need clearly expressed by the port authorities, the Port of Heraklion. The shipping industry seeks to contribute to greener ship routes, where CO2 emissions and minimize them and reduce them, and fuel consumption using operational voyage optimization. This is based on high-resolution numeric forecasts for atmosphere waves and hydrodynamics, integrating. Yeah, sure. Take it. Yeah, there. So, shipping industry seeks to contribute to green. Press pause. With operational voyage optimization. This is a high-resolution numeric forecasts for atmosphere, waves, and hydrodynamics, integrating also in situ sensors for triggering those models. In this section now, we go to the pilots page in Iliad Marketplace, where you can find the product, writing ship routing or harbor safety. And you're transferred to our page where you can access also every link that is relevant to the pilot and see screenshots of working examples. In the green button, top right, you can be transferred to the Adam API Jupyter page, where users of the digital twin environment can discover and download datasets through Adam. Its backend service accesses the S3 bucket and downloads models output and indexes them in the Adam catalog. By using this Jupyter notebook, users can discover all available datasets, importing the Adam API module. They can read the harmonized metadata and proceed with data discovery and access. This is maintained by our partners, Mio. And you can also visualize in this Jupyter notebook a simple case of a SWAN model output. Adam acts also as a visualization platform where there is a separate marketplace page. There is also the green button link on the top where you are transferred to the offsite link, the data exploration service. Here you can load all the high-resolution models around the island of Crete. We're currently running WRF for atmospheric, and then also you can see this one, the 50-meter model. We also have hydrodynamics models in 1 kilometer resolution and wave models. This is an interactive platform. The model also use data simulation to correct from atmospheric the atmospheric side. And here you can plot the pressure at mean sea level, for example, and have it change interactively the data and the forecast hours. An important part of this pilot is also sensors, where they are used to trigger the models whenever dire weather conditions are met. Here is a short video of the installation of 3 hydromasts sensors at the port of Heraklion, provided by Taltech. And now this is the Docker that has been created by Intrasoft running on the stream handler, where stream handler lies in the durability layer, facilitates communication from data sources, and modeling analytics tools. As presented, the platform is consuming real-time data from the installed location and detects abnormally high currents above a certain predefined threshold. This is also another implementation of a listener based on that Kafka and stream handler, where you can see a script in Python in our local HPC that also saves alerts in this JSON format you see on the right. Now we move on to the application packages. All our models have been packaged. This is the SIP routing from the marketplace, where you can click on the link of the GitHub repository of Iliad. And here you can see the CWL implementation with all the inputs and outputs that the inputs that it requires. You can access the CWL workflow. You can also see the contributors and the inputs and outputs there. This is registered as well in the Iliad registry maintained by NESC-Tech. You can search on it as a workflow with a program name. You can find it. This has global coverage, as you see on the left, because we have created as it can use the local models for high resolution and global forecasts for lower resolution mode. It requires the credentials as inputs. And you can also select the departure date, the starting location of an end location with latitude and longitude, and also put some details about the ship as the max draught, the depth that the ship can travel, and insert your own bathymetry if you like. And there you can see also the contributors of this CWL. This is a simple running of this workflow of the SIP routing one, where you can see it's been sped up a little bit. It takes about 5 to 10 minutes to complete, depending on the machine's capabilities. And then you get statistics on the minimum distance and minimum time and distance routes. The second application package we have created is regarding the harbor safety. It also uses the high resolution models around Crete. And this is the GitHub repository link, where you can also find the Swan Heraklion model. This is two nested models on 500 meters and 50 meters around the port of Heraklion specifically. With a simple command, the CWL tool command and the Docker engine running, you can run this model. It's also registered, as you see here, on the Iliad registry. You can search Swan and find it as a workflow. And here again, you can see the details on the model, the specific inputs that it requires, the credentials that are needed, and the contributors, and the actual link to the CWL tool. Here's a simple run of this. You can see how simply the ease of use of it, and the output that it saves as an NC file on your PC where you run it. All the Dockers that are behind those are hosted on Docker Hub. With our, this is the visualization now, the front end of the SIP routing with GeoMachine. You can find the link again on the marketplace. You can follow it and create an account and contact us to give you access. Right now, we have on the left the details and the specific formats of the input that it requires that are outputted from the CWL. And you can give it a unique name. This is a Chania to Heraklion route. And this also integrates the alerts that are the JSON files that I mentioned earlier. So you can see the alert beeping there on Heraklion on the location of the hydromasts. And you can click on it and see the value of the currents that are from stream handler set up to be high. And then you can see that two routes from Heraklion to Chania, the one minimizing distance and the other CO2 emissions, and see at each step the time and date and also the statistics. Another thing you can do is load previous runs that you have there with other scripts. It automatically understands the starting port. This is for Thessaloniki to Heraklion. This takes in from that public database, from CMEMS, and you can also visualize the currents. And again, click on each point along the route to see the minimum, the statistics of the CO2 and distance traveled. Again, you can see the alert down on the bottom on the Heraklion port. The future steps is to also integrate with the Swan visualization, which will be hosted on Adam and can be found as discussed on the Adam API. And again, there going to be a red dot with a JSON file showing. And also the last step is to integrate with cloud computations. The CWL is very easy to be transferred on the cloud and interconnect GeoMachine so that you can pass inputs on GeoMachine and then prompted go to the TeraDue server, and you can collect then your outputs or automatically with an API with an S3 bucket to visualize them on the Geo machine. This will be the envisaged finished product. Thank you very much. You can scan our QR code there. I don't know if everything is showing the QR code with a feedback form for the presented pilot. Thanks.
Thank you, Antonio.